Hi, if you're seeing these solutions on YouTube, click on the description below, take these as a test and then check out the solutions for free.
How many of the following statements is or are true? Right. A number divisible by 6 and 8 is always divisible by 12. Wonderful. A number that's divisible by 6 and by 8. Number that's divisible by 6, number like 6, 12, 18, 24, 30, 36. These are all multiples of 6. All of these will be divisible by 6. 8, 16, 24, 32, 40. These are all multiples of 8. They'll all be divisible by 8. Right, so we want a number that's divisible by 6 and by 8. So we're looking for numbers that are multiples of 6 and multiples of 8. So number like 24 is there on both lists. 48 will be there on both lists. 36, 42, 48. 72 will be there on both lists. And so any multiple of 24 will be a multiple of 6 and of 8. The LCM of 6 and 8 is the idea. That is the idea we are looking for. 6 is 2 into 3. 8 is 2 cube. I'm prime factorizing this. So the LCM will be 2 cube into 3, which is 24. So a number that is divisible by 6 and 8 will be divisible by 24. Any number that's a multiple of 6 and a multiple of 8 will be a multiple of 24. Anything that is divisible by 24 is always divisible by 12. This statement is true. If a number is divisible by 6 and by 8, then it is definitely divisible by 12. Wonderful. Let's go to the next one. A number divisible by 4 is also divisible by 8. This doesn't look like it's true. A number divisible by 4, it's a multiple of 4. So 4, 8, 12, 16, 20, 24. This is not a multiple of 8. This is not a multiple of 8. This is not a multiple of 8. 8 is 4 into 2. So a number should have a 4 and an additional 2 for it to be divisible by 8. A number divisible by 4 is not necessarily divisible by 8. The opposite is true. If a number is divisible by 8, it is definitely divisible by 4. And so, but this statement is not true. Number that divides the sum of two numbers without reminders also divides each of them exactly. Right? Interesting. So two numbers, let's say 20 is divisible by 4. 20 can be written as 8 plus 12. A number that divides the sum of two numbers also divides each of them exactly. 4 divides 20, 4 divides 8, 4 divides 12. Is this true? Is this always true? Think about it. 20 cannot be written as, can also be written as 7 and 13. 20 is divisible by 4, but 7 and 13 are not. A number that divides the sum of two numbers without reminders need not divide each of them exactly. So 20 is 7 plus 13. 7 plus 13, 20 is a multiple of 4, but 7 and 13 individually are not multiples of 4. Wonderful, wonderful statement. Sometimes it is true, but not always. The product of three consecutive numbers is always divisible by 6. Oh, this is interesting. 1 into 2 into 3 is 6. 2 into 3 into 4 is 2 into 3, 6. 6 into 4, 24. 3 into 4 into 5. 3 into 4, 12. 12 into 5, 60. 4 into 5 into 6. 4 into 5, 20. 20 into 6, 120. We've written down a few numbers. This is a multiple of 6. 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 Oops. So it looks like this could be true. Just with 4 examples, we cannot say it is true. But some examples help us get an idea of whether it is true or not. Right? So now let's assume it is true. Let's see if we can prove that it has to be true. Product of 3 consecutive natural numbers is always divisible by 6. In total numbers, I've assumed it as natural numbers. Right? Wonderful. Might this be true? 3 consecutive natural numbers. Here, either these two are odd and this is even, or these two are even and this is odd. In any case, there is one even number. That much we know very clearly. So the product will be even. That is clear. So product will be a multiple of 2. If we can now establish that the product will also be a multiple of 3, we are through. Then it has to be a multiple of 6, 2 into 3. Any 3 consecutive numbers, there has to be one number that's a multiple of 3. 1, 2, 3. This is a multiple of 3. 2, 3, 4. This is a multiple of 3. 3, 4, 5. This is a multiple of 3. 4, 5, 6. This is a multiple of 3. Any 3 consecutive numbers, there has to be one number that's a multiple of 3. Always. See if you can prove this very rigorously. So if you divide any number by 3, then the remainder has to be 0, 1 or 2. The next number, 0 plus 1 will be 1, 2. 2 plus 1 is 3, which is same as 0. 2, 0, 1. So in any combination you take the starting number, if the first number leaves a remainder 0, then that's a multiple of 3. Then we have 0, 1, 2. The first natural number leaves a remainder 1. The next one will leave a remainder 2. Third one will become a multiple of 3. The first one leaves a remainder 2. Second one will be a multiple of 3. Third one will leave a remainder 1. So in any 3 consecutive natural numbers, 1 will be a multiple of 3. So product of 3 consecutive numbers is always divisible by 2 and divisible by 3. Therefore divisible by 6. This is true. How many of the following statements are true? 2 of these are true.